Hi, welcome to my channel, JaberTime. Today I'm going to go over the topics, as you could see: solving equations involving rational exponents, solving absolute value equations, solving equations in quadratic form, and ones in quadratic form with binomials, solving rational equations leading to a quadratic form. Other types of equations: rational exponents. I'm going to go a little bit fast because I'm trying not to make it 45 minutes, but I have everything in detail, as you could see. We have a to the power m over n. Could be written in a lot of different ways. I could break down m over n to two pieces as m outside, 1 over n inside, or the other way around. Now, if this is outside, that's 1 over n, which is the nth root of a to the m. If this is inside, that's going to be the nth root inside to the power m, as it shows right here. For example, this right here is being called the square root, which is the 16 to the power half. If this is 2, but because it repeats a lot, we kind of ignore it or drop it for the convenience. And 16 to the power half is square root. Now, sometimes students, they ask questions like, I can't find the cubic root on the calculator. Well, you don't have to look for it if you could just use the concept that the cubic root will be to the power 1/3. Here's the cubic root of 8. Differently, it's 8 to the power 1/3. You could test that on the calculator for practice. Should get 2, because 2 times 2 times 2 will take you back to 8. 8 to the power 2/3, like this right here. Sometimes you want to break it down to this way, sometimes you want to break it down to this way. It depends on the numbers. In this case, we're going to take the 1/3 inside and the 2 after to the outside part. This is cubic root of 8, which we agreed on to be 2. Now it becomes 2 to the second, which is 4. Hopefully I'm not going too fast. As I said, like, I want to expose to you a lot of problems, a lot of examples. So that's why I'm going a little bit fast. But hopefully not too fast, okay? Solve x to the power 5 over 4 equals 32. We want to get rid of the exponent right here and leave x alone. So the way to do it is we raise both sides to the power 4/5, which is called the reciprocal. Why is that? Because this 2 multiplied will give you 1. This is x to the power 1 equals 32 to the power 4/5. Now we want to break this down to two pieces, 1/5 and 4. We'll take the 1/5 inside, because the 5th root of 32, that's what it means, is actually 2. 2 to the power 4 is 16, and that should do it. X to the power 3 over 2 equals 125. That's more practice. We're going to raise both sides to the power 2/3, which is the reciprocal. This will multiply by this, will make it 1. This right here, we're going to break it same way, 1/3 inside, cubic root, and 2 as a power of 2 outside. Cubic root of 125 is 5. 5 to the second is 25, and that should do it. Three x to the power 3/4 equals x to the power 1/2. Now we have x's on both sides. We need them on one side, so we subtract x to the power 1/2 from both sides. Now x to the power 1/2 with x to the power 3/4, we need a common denominator for those exponents, and it's 4. So I'm going to rewrite 1/2 as 2 over 4. This way I could factor out x to the power 2/4 from both terms. And why I could do that? Because if you multiply back, you add the exponents, as you could see. X to the power 2/4 times x to the power 1/4 is x to the power 3/4, because of the rule that says x to the power m times x to the power n equals x to the power m plus n. So when you multiply these two terms, you add the exponents because of the same base, it will take you back to 3/4. And now when you take this out as a common factor, that leaves you with 1 inside. Now the principle of zero product says a times b equals 0. That means either a is 0 or b is 0. So we're going to apply it. Well, this gives me one option, which is x equals 0. This right here, we're going to add 1 to both sides. Then we're going to divide both sides by 3. Then we're going to raise both sides to the power 4 over 1, which is simply 4. That simplifies to 1. And that's the 4th root, or the 1/3 to the power 4, which is 1 over 81. So the solutions are 0 and 1 over 81. 5x to the 4th equals 80x to the 2nd. We're going to move x's to one side again. Subtract 80x to the 2nd from both sides. Factor out the common factor, which is a 5 from the numbers, and x to the 2nd from the variables. This is called in math difference between two squares. Looking at this as 4 to the 2nd. Factor it as x minus 4 times x plus 4. Now we have 3 options. Either this is 0, or this is 0, or this is 0. That's a principle of zero products. That will give me 0, that will give me 4, that will give me -4. This right here, it's called in math double solution. In our case, it's 0, so I'm going to call it double 0. Now, what does it mean? In math, in lower math, we just say like we have 3 zeros or 3 answers. In higher math, we distinguish between this type of 0 and these zeros. Why? This is called double because that's 5 times 0 times 0. X to the 2nd is x times x. So actually it gives you 2 zeros. But here's the meaning of the double 0. Since this is a 4th degree, in polynomials we say when you set it equal to 0, you should have 4 zeros, not 1 or 2. Sometimes they are sometimes they are real numbers, sometimes they are imaginary numbers. But you should have 4 total. That's a 4, 1, 2, 3, 4. Those count as 2. This is to support. In case you have a 0 at -4, the graph crosses -4. Same thing for at 4. Where this is a double 0, it bounces back. So if you see a graph like this one for a 4th degree function, that is a double 0. So you could write it yourself. If you don't have the equation and you want to write the equation for this, you could start by thinking a factor form. Of course, you need the 5 and some other coefficients to work on, but at least you'll know that this is 0, or there is an x to the 2nd involved in factoring. There is an x minus 4, and there is an x plus 4, and things of that nature. It's another example of polynomial. This time we're gonna factor it by grouping. What do I mean by grouping? I covered that in the last two videos, and I'll put the links at the end of the video. I usually put like 2 or 3 links for that, factoring and factoring by grouping. This is what I mean by factor by grouping. So you put this and this kind of like separate groups. From this one here, I'm gonna factor x out. From here, the green ones, I'm gonna factor -9 out. Now notice when you factor x to the second out and you factor here -9 out, what's left is the same, x plus 1 and x plus 1. Now I'm gonna factor x plus 1 out from the right side, as you could see. From here I have x to the second, and from the second part I have -9. Now this is also like last time. It's called difference between two squares, looking at 9 as 3 to the second. Still could factor it as x minus 3 times x plus 3. I have 3 answers and none of them repeats. So I have from this one 3, from this one -3, and from this one -1. Let's look at the graph. 1, 2, 3. Starts with leading coefficient positive, so it starts going up, then down, back up. That's the behavior of cubic polynomial. Let's look now at square roots. Solving the square root of 15 minus 2x equals x. To get rid of the square root, we're gonna square both sides. Left side is now clean, 15 minus 2x, and the right side will be x to the second. Let's put this to the right side next to x to the second, so we could have the polynomial with pure x to the second, not negative x to the second, by adding 2x to both sides and subtracting 15 from both sides. Factoring this, I get x plus 5 and x minus 3, which means I have two options. The principle of zero product says either x plus 5 equals 0 or x minus 3 equals 0. That gives me 3 and that gives me -5. Let's check our answers. Now this one here, before we did not check our answers, but why do we not check our answers here? Every time you deal with square roots and you square both sides, things might happen that if you have negatives becomes positives, and when you take it back it doesn't go back to negatives. The short story is, when you deal with square roots and square both sides, you need to check your answers. This is the short story. You have to be careful even if the problem doesn't say check your answers. Let me show you what is going to happen. We're going to take x equals -5 and test it. I'm going to go back to the problem, thinking what's going to happen if I put the -5 instead of x every time I see x. Well, this is going to simplify to 25. 15 minus 2 times -5, which is 15, plus 10, that's 25. But the square root of 25 is not -5. This is a 5, and that does not equal to -5. We call this in math an extraneous solution. That should be rejected. This number should be rejected and it's not part of the solution set. Let's look at the other number, which is 3. X equals 3. We're gonna go back to the problem and plug in 3 here and plug in 3 right here and see if that works. Well, I have square root of 9 equals 3. Let's take a look. 15 minus 6 equals 9. Square root of 3 is 3. Yes. So we only have one answer, which is 3, and we should reject -5. So one more time, every time you deal with this type of problems, you need to check your answers, because some of them might not be accurate answers. Solving an absolute value equation. The square root of x equals 5, that means either x equals 5 or x equals -5. Why is that? Absolute value of 5 is 5. True. Absolute value of -5 is 5. True. If you want to check your answers, you just put it here and test it. They both work. So let's apply this method and solve some problems. Absolute value of 6x plus 4 equals 8. That will give me two options. Either 6x plus 4 equals 8 or 6x plus 4 equals -8. Here, subtract from both sides. I get 6x equals 4. Divide both sides by 6. I get 4 over 6, which simplifies to 2/3. On the right side, subtract 4 from both sides. This becomes -12. Divide by 6, divide by 6, and simplify that. I get x equals -2. So I have two answers, and that should do it. 2/3 and -2. Let's take another example. Absolute value of 3x plus 4 equals -9. Notice I wrote this in a different color, kind of like highlighting it or trying to make sure that we are paying enough attention to something's happening right here. There is no solution to this problem. Why is that? The absolute value cannot be negative. You can't have an absolute value that is negative, so you can't move on. There is no way you could find a number that you multiply by 3 and add 4 and take its absolute value and end up with negative. So, no solution. Absolute value of 3x minus 5, subtract 4 equals 6. How do you do this problem? Well, we need to clean it up and have the absolute value by itself. Isolate the absolute value expression and then write two equations. We add 4 to both sides, cancels here, and that's a 10. Now I have two options. Either equals 10 or equals -10. We're going to add 5 to both sides, both ways. This simplifies to 3x on the left, 15 on the right. Divide by 3, I get x equals 5. Here I get 3x equals -5. Divide by 3, I get -5 over 3. And those are the two answers. Well, we took care of some with positive on the right and negative on the right. Now let's take care of if it's equal to 0 on the right. The equation is set equal to 0. So we have to write only one equation. There is no plus minus 0. So we write it without absolute value. Subtract 10 from both sides. I get minus 5x equals -10. Divide by -5, divide by -5, as you could see. Simplify this, and the answer is 2. And that should do it. The answer for this problem is just one answer, which is 2. Here's something different. Solving equations in quadratic form. Solve the 4th degree equation. This is a 4th degree. How do you handle it? Well, I could say this is x to the second and this is x to the second to the second. So in other words, I could use substitution and call x to the second another name, which is called u. Now here, what happens to the problem, I'm looking at this as 2x to the second. I'm looking at this as 3x to the second to the second. Using the u language right here, that becomes a quadratic. Instead of calling it 4th degree, now it's 2nd degree. Instead of solving for x, we're going to solve for u. 3u plus 1 times u minus 1 is how you factor this. You could double check. Factoring was in a different video, that's why I'm not slowing down on factoring. So we have two options. Either 3u plus 1 equals 0 or u minus 1 equals 0. We're gonna subtract 1 from both sides. I get 3u equals negative 1. Divide both sides by 3. U equals negative 1/3. And this one will give me, after you add 1, u equals 1. Now here I need to take it back, because we can't stop right here and say the solutions are negative 1/3 and 1. That's not x, that's x to the second. That was used by me to simplify my work. We need to go back and use x. So this is x to the second equals negative 1/3. Take the square root of both sides with a plus minus, and that's the answer. But a square root of a negative number is a complex number. If you break it down, this is square root of negative 1, this is square root of 1/3, and square root of negative 1 is an imaginary number because there is no number that you could multiply by itself and get negative 1. We call it I for imaginary. Okay. On the right side, we have x to the second equals 1 instead of u equals 1. Take the square root, same idea, plus minus 1. So now, how many solutions do we have? It's a 4th degree, and here's the solutions. 4 zeros. I square root of 1/3, negative I square root of 1/3, negative 1, positive 1. Because that's plus minus means 2 answers in 1. 2 answers right here, and that's 4 of them. Solve x plus 2 to the second plus 11 multiplied by x plus 2 minus 12 equals 0. Notice this right here is repeating right here, so that's going to be called u. U equals x plus 2. This simplifies to a new form that is called u squared plus 11u minus 12 equals 0. Factor it. I get u plus 12 times u minus 1 equals 0. Two options. Either u plus 12 equals 0 or u minus 1 equals 0. Subtract 12 from both sides. I get u equals negative 12. Replace u with what was given or agreed on, which is x plus 2. So x plus 2 equals negative 12. Subtract 2, I get x equals negative 14. This is a typo, by the way. X equals negative 14. Let's go here. U equals 1 after you add 1. X plus 2 to replace u equals 1. Subtract 2, I get x equals negative 1. So the final answers is x, not u, of course. X equals negative 14 and x equals negative 1, and that should do it. If you feel like I went too fast, you could always pause the video as you watch it by hitting the space bar, and by hitting the space bar again, it will play it. Trying to show you enough problems, and I'm trying to go a little bit fast to save you some time from making a video of like 45 minutes. It's about 25 minutes, which is decent for that many problems. And I take my time to write the notes to save you some time. Hopefully you liked it. Hopefully it was helpful. And I'll see you next time. Thank you. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.